Good morning, my outstanding friends. This is a very serious discussion today about hurricanes, specifically Milton, Helene, and the most recent destruction. This is not going to subside. This is not going to subside. I want to talk to you about the reasons these things are happening. Okay, I'm going to make this very simple. This layer right here and this layer right here is our atmosphere. The Earth is spinning in this direction this way. The atmosphere is not stationary, it sort of flows around. And this is the impact of the United States on the atmosphere here. It's making it swell up like crazy because when the Earth spins over in this direction, this is like flat. The air here is like a layer. And then it hits the East Coast here and swells up into this. You see, this is California. This is the other side of the United States. And that's where this impact happens. Now, what the effect of that impact is, I'm not sure. But I can tell you one thing. The Earth is going this way. The atmosphere is moving this way, and the impact creates that large bump. Now, the other thing you want to see here is, if you can see the color of this and then the color right out there, that's where the sun's hitting, and we're spinning in this direction, scrubbing against this atmosphere, and it's much more energetic than over here. All right, that's why it's brighter and more energetic than this side, because that's the trailing side. The Earth is going this direction, spinning this way. And this is the trailing side, and this is the impacting side. As I will show you, the sun does exactly the same thing, because we're both spinning through the universe the same way. Okay, my friends, as you know, we are under some terrible threats from extreme weather patterns. It's all over the place. It's not just here in the United States, it's all over the world. Now, we are right now under the threat of Hurricane Milton, which is going to hit Florida in the next day or two. And it's literally going to be a disaster of biblical proportion, just devastating. And anybody that thinks it's not going to be is deluding themselves. And the people that are deluding themselves are, if they try to stay and weather this out, they're going to be in trouble. Quite likely. These kind of things, people have never seen these kind of effects before. And, you know, I'm a pretty strong-hearted guy. I would say, well, not this time. Not in these events. I would not try to hunker down. I would try to get the hell out of town. But where do you go? Just think of the impact on people's lives. Just think of losing everything that you have in your whole life. And there will be hundreds of thousands that will be in this position and are right now. After Helene, it was an absolute nightmare. I mean, you see the devastation. It's just stunning how furious Mother Nature can get. And she is furious now, and I don't blame her. And why is she furious? Because of what we did. That's why. And when you want to know what we did, I'll show you what we did. All right, so we're spinning through the universe on the arm of the Milky Way. Let's just look at some ground rules done here. Okay, anybody that looks out into the universe in the night sky can see all these stars and all this debris that's out there. There's no question. It's saturated with particles and fields in space, and we have taken some with actual cell phones that show the fields and all the debris that's in space. It's just not considered. Now, for NASA and all the rest of them to say that light doesn't slow down coming through all this stuff, that's insanity. These are magnetic fields. These are fields that are propagated by spinning planets and so forth. There's a planet behind the moon here, and I'm not sure which one it is, but you can see all of these dipoles in space, which are stars and whatever they are, But CMOS, complementary metal oxide silicates, semiconductors, pick up these fields, and if there's some kind of a app on the phone that sees them as patterns of magnetic interaction, basically, these are nothing more than magnetic fields. And then, and in addition, you see the blue here, and the, like, almost more turned toward the red here and the yellow in the middle. That's the moon moving this way, pushing against light and forcing it into the blue region. We're spinning through space, and here is the actual interaction that we're doing. All right, here's the sun. Now, if you're a flat earther, that's fine. Please don't thumb me down and insult, you know. Yesterday I got attacked by, I should be ashamed of myself for not showing that the earth is flat and on 4 pillars and all kinds of things. And they, flat earthers are the ones that thumb down. They never give me any thumbs up, and they just don't like the fact that I won't say the earth is flat, which and there is space and all that. It's kind of upsetting to have those kind of people attacking my channel all the time when I'm trying to show the proof, and they're trying to support academia. They're being used by academia. Academia says, oh, if you believe this guy, you must believe the earth is flat. Because he says there's giants, he says there's dragons. Well, obviously the earth is flat. Yep, the earth is flat. And then, so please, if you feel that way, that's fine. Go somewhere else. I have no problem with that. Now, we are on the earth. All right, and the earth is right here. And what's the way out here? Well, there is space, and there's atmosphere, and there is actual particles of everything, including the light. Light is nothing more than particles. That's why there's such a variation in the temperature out here. Right there, this exact line is the interface between our atmosphere and scrubbing through the particles in space. Right there is the scrub zone. Guess how hot it is? Right there in Fahrenheit temperature, it can get up to about 2,700 degrees. 2,700 degrees. Nobody has any idea why. They don't know why. It's scrubbing here, because there's nothing but particles here. Now, so it gets 2,700 degrees, and then less and less and less. You say, well, why? Down here, it goes to minus 80 Celsius, which is minus, like, I think, 112. So we're up over 2,700 degrees. Then it drops at this zone, which is the dipole, hot, cold. Then what happens? Well, you're going to have hot again, and that's where we are. And then it gets going into the earth, which basically is a cold absorber. However, it's heating up. The more electrons come down here, the more heat, the more scrub, because that's where it is. The more heat up here is the scrub. And if it scrubs harder and it gets more heat, it will eventually get down to here as heat. But in the meantime, it will get colder than cold. I mean, minus 112. And what's here now is a dense, more moisture. And you're getting, you know, a lot of rain, and then you're going to get huge balls of ice coming out of here, because at minus 112 degrees and lots of moisture, you get that heavy hail, and it's coming down now. So why is this happening? Why are we getting hotter and hotter out here? I'll bet you if they measured this, they'd find out it's getting hotter and hotter and hotter by the day almost. Because every time you burn something, it gets bigger and bigger and bigger and bigger and bigger in the atmosphere. It doesn't go away. It's being pushed down into here. They think it just drifts off into space. No, that's not true at all. It's being forced down in here, exactly as the sun. And you see, well, let me show you what the sun does. Don't forget, here's our real hot zone. This is as hot as it gets, 2,700 degrees, 1,500 Celsius. And that's why the meteorites and everything burn up coming through there. And when we send spaceships up through there, they have deflectors and all kinds of things to the heat absorbers and all that so they can get through this layer. They just have to poke through it. It's not like they're going to be sitting around out there for forever in that layer. They get up into this layer and they're in what they call the exosphere, which is extremely low density. But still there's a ton of stuff there. It's not completely empty by any means. By any means whatsoever. There is no empty space. It doesn't exist. Light is particles. Now they've known this forever. This is back to over 10 years ago. Empty space isn't empty. It's not empty. This is Fermilab, and they say exactly what happens is what I say happens. There's subatomic particles out there, winking in and out of existence. Subatomic, what does that mean? Smaller than atoms. So they're bits of light. They're tiny little bits and pieces of light. And they're just floating around out there and they're getting banged into with other bits and pieces. And they're winking in and out of existence. That's what this is. Empty space, not empty. Light is a particle. I've shown this so many times, it's amazing. And the same guy here, Don Lincoln from Fermilab's, claiming empty space isn't empty, and he's also claiming these are the smallest particles that exist, and this one has all the mass, and this one has nothing but energy. And it's a zero particle, but it just has a field. So it has no weight, that has all the weight. And it's the same guy, Fermilab. And that's over 10 years ago. And we found those particles, and I'm blocked from talking about it. And here we got global warming. They don't understand it. And I'm blocked from being able to speak about it. This is why I'm so upset. We found these same particles. We found them at the same time they found them. And I just reported this to them and NASA and CERN and everybody. And these are the same particles, no question whatsoever. And we were able to separate them. And I believe this we can create raw energy. Raw energy. All right, this is fission. When you break these particles apart, which are subatomic particles, that's subatomic fission. You broke those particles apart. When they come back together, that's subatomic fusion. And you're looking at it right there. There's the fission, there's the fusion. This is what we need to put into the battery to make it run. There's no weight there, no weight whatsoever, nothing but energy. And I am blocked from being able to speak about this. These are muon neutrinos, electron neutrinos. And there's a black ball in the shower. That's what happens. A muon goes on its own, and a white one goes into a shower. There it is. This is light accelerating. Einstein was wrong about literally everything. And everybody bases all their stuff on these laws and rules and the speed of light. The speed of light is very, very variable. Extremely variable. Very easy to accelerate. And you can slow it down very easily. And the particles in space do slow it down extremely. Look at this. You think the particle going through that in space is not going to slow down hitting those magnetic fields? Ask CERN about magnetic fields and how they interact with particles. They speed up particles and they slow down particles. They know. I've interacted with the University of Geneva. I went there, took particle physics, and I told them all about our stuff. I told them all about everything we were doing. And at first there was a lot of pushback, but by the time I was done, there was no pushback. And because I reported on the CMOS, they said, can't use it. I said, yes, you can, but you got to be in the light realm, or you got to harden it, which they ended up hardening it. Shut down for 3 years, hardened it to put in the CMOS detectors so they could see and not interfere. All we used was a cell phone to get all this. But we started with light. They started with huge particles like this. And because of that, they want to spend trillions of our dollars. Well, you start with this, you end up with garbage. You start with this, you end up with that. We can see what's happening. They can't see. All they see is debris. It's just a big ball of garbage. And then they dig through it for 50 years. And they still want more money. We give us more money, we'll find it sooner or later. And I'm blocked from commenting out this. And this is from everywhere. As far as I know, nobody will speak to me whatsoever. I can't get in, not a single one person. And Don Lincoln runs Fermilab's interface, and they're supposed to be the biggest big shots in the world along with CERN. I've been blocked, and Don and I do not get along because I don't like people that don't do their job. Now, I think I told you about the Earth's temperature. On the surface, 100 or so. And way out here, it's like almost, well, it's 2,700 degrees sometimes. And it varies. If the sun is hitting, it's very hot, like around 2,700. If it gets into the shade, it goes way down to, like, say, 100 degrees or so. It's a big difference. The sun is the thing that heats it up, because all of the things that come out of the sun are particles. And the sun itself, way out here, is millions of degrees. The surface is only 10,000. Millions out here. It's the same reason it's scrubbing through the universe. Now, what does it look like as we're being pulled on the arm of the galaxy? Don't forget, the arm of the galaxy is like this. We're being pulled this way. So that means our sun is being dragged this way. Well, we're going to follow the sun. And how does that happen? Here's exactly how it happens. There's the sun being dragged through the arm of the Milky Way. Here is all the planets trying to catch up to the sun. Well, the sun is spitting off debris on its side because it's being scrubbed. And you can see that because we come through, they call it the solar wind. It's particles. And this is spitting out, it's spitting out dipole electrons primarily, but also bits and pieces of particles and protons and, you know, chunks of matter and globs, who knows how big they are. But they're coming out of here in huge quantities, and we're scrubbing through them. They're particles. They're not nothing, they're particles. Empty space is not empty. It's fully understood. All right, here's the key. Out here, don't forget, 2,700 degrees, 100 degrees or so down on the surface. Huge increase in temperature. And then it gets very cold right under that temperature, and then it gets hot again on the surface. That's the dipole nature. Same thing with the sun. The sun is 10,000 on the surface. Way out here, where it scrubs, just like our scrub, it goes down, it goes up to millions of degrees, from 10,000 up to millions. They have no explanation for this. They want to spend billions of dollars to go investigate why this is so hot. They come up with all kinds of things about fusion and this and that. No, it's scrub. And that's why the negatives are being scrubbed, or they're torn away from each other. And that's what creates all these different ions out here and all these different negative particles. It's just nothing but saturated with negatives. Negatives everywhere. So what does that mean? A negative pushing into another negative bounces. You get a glow, and it heats. Whenever you get a glow, you get a heat. And that's what you got. Okay, my friends, what I am presenting to you is 100% certainty, and it's mostly not understood. This is what is in the solar system and in the galaxy everywhere. These are fields created by the particles that are out there. They just are there, and they wink on and off as light slows down coming towards us. That is not understood. Light can accelerate, as is shown right here. Quite simple. This is from a red laser, pulse red laser, and in a Venturi, which is an accelerator, fully understood. I'm not making up any of this stuff. These are the neutrinos, muon and electron neutrino, creating a muon on its own, sterile, and the electron showers. There it is right there. And this is not my little doodle there. It came from Fermilab, or CERN, one or the other, and the black particle stays away. That's fission, that's fusion. I've shown this, and we need to be able to harvest this energy to stop burning. If we keep burning, we're done. It's all over. These are the particles. There is no question. Those are the particles that Don Lincoln found at Fermilab. I think I showed you that, and I'm blocked from being able to even speak. He's got me blocked everywhere over there, and for over 10 years now. So that's very upsetting. And this is some very interesting stuff. This is what the Russians found in space. And this also, I tried to communicate with Don Lincoln. I said, look, the black particles can move to the center. Nobody understood it. During the experiment, we contacted the Earth guys. They couldn't believe it either. Everybody freaked out, and they still don't know what to think about it. One guy locked himself in his office for 3 weeks, freaked out over a Max Planck. Now, again, and also they say space smells like steak. Well, why? All of the things that I have discovered have been validated. I say there is nothing but biology, and in space there is nothing but biology, and this actually formed in the same Russian space thing. When they put it down to extremely cold temperatures, it started to form what looks like DNA. These are the charged particles. You got to get way down in the temperature. Inside the capsule, they got this effect. Now, can life self-generate in the cold vastness of space? There is nothing but these particles everywhere. They're everywhere. And they say space smells like steak. And I can tell you, Comet Bennu or Asteroid Bennu, whatever you want to call it, the samples are back here on Earth, and that is a heart. No question. The heart sarcomeres are here. The phosphate surprise, which is the membranes, are in there. It's made from clay. It's nothing but blood. It has all the same chemicals of blood. And I need to talk to somebody about it. Again, I'm blocked. I can't get anybody to respond to that. And Comet Bennu or Asteroid Bennu, the samples are here on Earth. I predicted what they would be before they came back. And they are. And the heart sarcomeres are there. They are there. There's no question whatsoever. So there's so much that is not allowed to be spoken about, and we're destroying the Earth because of that. And because people will not speak to me because of my other research that indicates that everything in the universe is biological. And that's just a fact. I'm sorry. I'm never going to back away from that. All right, here's my friend ChatGPT again. Is space a vacuum? Yes. Well, that's not true. It's often described as a vacuum, very low pressure density compared to Earth's atmosphere. However, it's not a perfect vacuum. That's true. Traces of gas, dust, and radiation. And the density of matter in space extremely low. Well, let me ask you this. And then I went about how hot is it, and it's extremely hot. Now I said, how do astronauts know space smells like steak? Which it does. Astronauts have reported that space has a distinct smell. Now listen to this carefully. Often described as resembling hot metal. All right? Welders know about this, the smell of metals when you weld. And the different rods or different metals have different smells. Now, but the hot metal welding fumes, or even seared steak, it smells like steak because steak is saturated with blood, and blood is literally saturated with the metals. And they say it's based on the experience of their suits and equipment after they come back from a spacewalk. They smell like steak. And they say it clings to their suits, and they described it in those terms as basically like steak. And actually Chanel, I believe, made a perfume, Eau de Space or something like that. Now, listen to this now. The exact compounds responsible for this odor likely come from the interaction of the vacuum of space. Why? What interaction? There's nothing there, they say, with the materials in the suits and the environment. No, it's clinging to that because it's saturated with those particles. And gas from your smoke from your gas grill, even though it's separated a little bit here and there, it's still molecules, and they cling to the suits. There must be a ton of them out there. They just don't pay any attention to them. But they say the exact compounds responsible for the odor likely come from the interaction of the vacuums with the suit. No. But the specific chemicals haven't been conclusively identified. They're steak. It's an intriguing aspect of the space experience. No, they're not taking into account the fact that it is actually body parts in space, and here they are, right there. They came back with a sample from this heart. That's Bennu, and it is a heart. Here's the valves of the heart. I study the mud fossils very carefully. This is why nobody will speak to me, because they just can't get their mind around the fact that this is true. But they have the sample from Bennu back here on Earth right now, and it is muscle sarcomeres, no question whatsoever, and it has layers of membranes on it, no question whatsoever, and it has the chemistry of blood, no question whatsoever. It is 100% certainty that sample from Bennu is from a biological heart. From what kind of creature, I have no idea. You see why this is a normal heart? That's what that was at one time. It had all this plumbing on there. But what happens is this is glue. It literally glue. And it glues this plumbing to those valves. So your heart it's doing this all the time. It's moving, it's jiggling, and people bash and smash, and football players get banged around. The heart has to be able to jiggle around and do all that stuff. But your plumbing stays sort of stationary, and the goo lets it do all that. It's just made to do that. It's a gummy, gooey stuff. When it dries out, it just pops off. I have seen many hearts because there's a lot of them that fossilize in the Mudfossil way. These just happen to do the same thing in space, and that pops right off. It's going to be floating around somewhere else, probably. And this is Psyche. It's the exact same thing, identical. And that's what the heart is once you pull off the plumbing. Now again, it's here on Earth. And let me show you something about it can't be missed if they just take their eyes open and look. That's not a crater. That's not, look at this. That's not a crater, that's a piece of plumbing. That's a tube coming out of there. Can you miss that? No, you can't. There's another one down here. You can't miss that either. Almost all of these are blown out. Not impact craters, they're blown out, or plumbing itself, tubes. Because the heart is not only filled with blood and pumping, it's so saturated with blood because muscles require a ton of blood to function. That's how they function, muscles. And this is just one big gigantic muscle with two big bags of blood in it. And one bag is full of good stuff, and the other bag is filled with stuff that's got to go be fixed up. All day long, or you die. That's it. And it's here on Earth. There's no mystery here anymore, none whatsoever. The mystery is why they won't pay any attention to this. Anybody that knows mud fossils understands the black, the red, and the yellow are iron oxides. Stop and think. Your blood is almost, well, it's saturated with iron. Iron is the big blood in the iron metal in the blood. I mean, it's just saturated with iron. These are the three colors of the state of oxidation. The red is fully oxidated, red blood. The black is completely devoid of oxygen, and the yellow is in between. And they landed here and took this sample out of there, and it has sarcomeres, and it has membranes on it. And it just blew them away. They said the phosphate surprise. You see this? Blood has all the metals in it, basically. I said, are trace metals found in blood? Yes, trace metals are present in the blood in small quantities. These metals play essential roles in various biochemical processes. Yes, they move things around. They're called the ligands are moved with the metal cores, and they're transition metals primarily. And they're transporting oxygen and everything in your immune system, protein synthesis, wound healing, metabolism, neurological functions, bone formation, all of that stuff is done with these metals moving things in your body. And this is what they look like, these transition metals. That's why you have all these different colors you see in rocks and things. Okay, I found this extremely interesting. As I showed you, in space, the sun spits out all kinds of particles that are basically diatomic little molecules. And some of them are bits and pieces and chunks, and who knows what's coming off of there. But they bang into the atmosphere that it's scrubbing through. Same as us, that's why it's so hot. We went through that. Now, let's look at this in more detail. Remember I told you, it appears that they form into DNA strand looking things. I don't know what that really means. I'm not making any claims, but this is in the space station in a warm, when it gets real cold, in the real cold regions of space, it comes down to doing this. Now, what is this? You see these little negatives here? To see O minus OH? All right, OH minus, what is that? Hold on one second. OH minus happens to be this. Hydroxide is a diatomic. Everything for me is dipoles. Diatomic. Two atomic anions with chemical formula OH minus. All right, so it wants to bond with something. It consists of an oxygen and a hydrogen atom held together by a single covalent bond. It carries a negative electric charge, so it either wants to bond with something or push something away. It is an important but usually minor constituent of water. No, it's a very important constituent of water. It functions as a base, also as a ligand, a nucleophile, and a catalyst. Those are the most important things in your body. Ligands, nucleophiles, which is nucleophilic substitution, and a catalyst, which means to speed up the things to make life work. This is what's floating around in space. These are the most important things in life. And they're floating around, all around, OH minus. They're all around our planet, they're all around here. Could life spontaneously combust out there? Those are the things that make life. And here's what it is. Look at the transition metals. These are the things that are in your blood. This is all of these metals are in your blood. You see this here? Well, I think almost everything's in your blood, but these are in your blood to transfer particles back and forth. And that's why they have these charges on them. And they have different colors because they have different bounces from their nucleuses. Let's put it that way. Nucleophilic substitution and reaction is where the blood comes in with some attachments to here, ligands. You see this here? The metal core is one of these metal cores. Then it has a bunch of little spots that it can stick to things. And these are what they call ligands. Now this is in water. So the transition metals are all these different metals. All of these are transition metals. It's not just these. And these colors can vary depending upon the charge on the metal ion and the number and type of groups of atoms called the ligands that surround them, attached to the metal ion in aqueous solution. This is water. The ions form complexes with colors shown to the right. Well, as these things move through your aqueous solution blood, through your body, they give up and take. It's called nucleophilic invasion and substitution. And they just said, as you just saw about nucleophiles, all right, these particular things are important because they function as a base, a ligand, which are those particles around, a nucleophile, which is invaded or in an invader, one or the other. I can't remember this. Anyway, and a catalyst. A catalyst makes things happen millions of times faster. If you didn't have it, it wouldn't happen. You couldn't live without a catalyst. Catalysts are the most important things in your life. Without catalysts, you die. Almost instantly. You see this? Catalyst, the OH minus works as a catalyst. I said, would we die if we didn't have catalysts in our body? Yes, without catalysts, specifically enzymes, life as we know would not be possible. We would not survive. You just die instantly. Enzymes are biological catalysts that speed up chemical reactions in the body, making them occur at rates necessary for life. Millions of times faster than they would happen naturally. Many vital processes, every one of them, depend on these reactions. 100% of the chemistry in your body depends on these reactions, 100%, including digestion, metabolism, DNA replication, energy production. Without enzymes, these processes would either take place too slowly to sustain life or not occur at all. In essence, catalysts are crucial for the biochemical reactions that keep our cells functioning and our bodies alive. We have to have these catalysts. So don't forget, OH minus is the catalyst. They work as catalysts. They're very important for life. And for some reason, these charged particles appear to attach and make DNA-looking strands out in the cold places in space. This is what happens. Cryogenic temperatures. I'm just showing you what it is. I'm not making up any claims. All right, let me just finish this up by going through every little detail quickly. As I said, this is the atmosphere that surrounds the Earth, and it's expanding very, very fast due to burning. And the more we come out here, the harder it scrubs, and the more turmoil, and the more events like Milton and Helene and all of these terrible, terrible hurricanes. It's just we have to stop combusting. Combustion turns something very small into something extremely large. Combustion, I'm not sure how big this would get if it was combusted into just gases, but I'm going to tell you what, it would get extremely large. And we're doing this burning, the amount of burning that's going on is unbelievable. And then the fires are happening because of the dry conditions here and there, and that's making it worse. So the more combustion, the more blown up. The more blown up, the more scrub. The more scrub, the more turmoil and all of this global warming. This will get hotter and hotter and hotter out here. Hotter it gets there, colder it's going to get just below. Colder it gets just below, the hotter it gets on the surface. That's the dipole effect. All right, if you have to go back through the video a little bit, you should. But this is the temperature differences all the way down to the Earth, where everything now is absorbing, so everything's warming up. Normally, it would, it sort of warm up very, very slowly, but now it's warming up fast. That's why the ocean levels are rising, because the glaciers are melting and adding to the watery substances that surround the Earth. So that's going to rise. Secondly, we're getting all of that heat and compression on the surface and the scrub, and the heat is going to continue to get worse, and the turmoil and the scrubbing, as I told you about the different temperature zones, we're cascading through space, through these fields. Light slowing down, all of that stuff is basically just silly. This is not empty space. They know it's not empty. And light, as I showed you, is a particle. There's no question about that. That's absolutely for certain. And we found absolutely for certain the particles that they found at CERN and Fermilab. Only we can see them, and we did it for a lot less money, and that is very upsetting to them. As I can understand, I understand that. But should we deny humanity this possibility of saving the planet? I don't think so. If we can accelerate light and create this is exactly what their mission was to do at Fermilab. And we did it. And that's the problem. They can't live with that result. No, and then here's the big one. They won't talk to me because they think I'm insane talking about biology and space. But now we have the product here from Bennu, and there's virtually no question whatsoever it's a heart. It has the tubing of the heart, it has the valves of the heart, it has the tendons of the heart, it has the gooiness of the heart, it has the colors of the blood, it has the blood and membrane and muscle sarcomeres back here on Earth. I'll show you those right now. Everything I have shown you, I support with my evidence, not just theories and guesses. We can see the light, we can see the atmosphere, and it's expanding. There's no question about that. And they didn't take into account any of this stuff. And they're not taking into account the scrub or light slowing down. I mean, everything that I have found in physics is just completely wrong, and they want to stay with this dogma that they've been told that these are laws, these are rules, you can't break these. Light doesn't go faster than a certain speed, and it always goes the same speed. I don't think so. I don't think that's right at all. I know it's absolutely 100% wrong, these things. And they now have to say these same things so that they don't look foolish. And I think they're looking foolish by not embracing an explanation of this. Just give me an explanation. Tell me why I'm wrong. And let's look at the Bennu. Let's take a look at that now, because it's nothing but sarcomere, no question whatsoever, with membranes and the chemistry of a heart, blood. Listen to this. This is what's in Bennu, the sample that they've been looking at. We're taking a long time to look at it. They came back in September, and they still have, it's almost a year now. Now, well, I think it might be a year. The 23rd, I think they came back. All right, they're taking findings of fascinating insights. Here are some of the key aspects. Organic compounds, yes, organic molecules, amino acids, that's in DNA and everything. The building blocks of life. Success, Bennu could have contributed to the origin of life on Earth. Well, maybe. Minerals. It contains all the minerals that are in your body, carbonates and silicates. All right, water. It has water because if water is in hydrated minerals, or your body is very, very hydrated. It suggests water was present during the formation. Carbon-rich material. We're carbon creatures. Bennu classified carbonaceous asteroid. Then they say volatile chemicals. Yeah, there's all kinds of volatile chemicals in body fluids. As researchers continue to analyze the sample, they will uncover more details about Bennu's composition and significance for understanding the origins of the solar system and life on Earth. How about life in space? All right, what I want you to look at is this right here is muscle sarcomere. This is the phosphate layer underneath and the phosphate layer above, which is the membranes that surround the muscle sarcomeres, and I will show you those right now. Okay, this is the space rock they call asteroid Bennu, and they landed on here and picked up a sample of particles, and they brought it back to Earth, and I know exactly what it is, and you do too, and you will in a minute. You see this black, red, and yellow? That's the colors of blood, and that is because Bennu is a heart. And they actually brought back sarcomeres and what they call the phosphate surprise. Phosphate, surprising. Well, what is phosphate? It's membrane. It's membranes. They're phospholipids, membranes. And there's membrane on the top and on the bottom of the sarcomeres. And you see those little blocks right there? Those little blocks are sarcomeres, which are muscle blocks. And they have a layer on the top and a layer on the bottom of the glowy stuff, which is the phosphate. And they look at it with a certain type of light, and it looks like this. Here's not with that light, but it has a layer on the top and a layer on the bottom, which is the way membranes work. Now, let me show you a little more, and then I will show you actual membranes. Here's what they're claiming. They're talking about it's from a young solar system. It's got all these building blocks of life in there, and they can't understand it. Well, it's because it's a heart. That's why it's got all that stuff. Now, it's huge. It's gigantic, yes. But here's the blocks. Don't forget, these are the blocks right there. Those are the blocks. There's a layer here and a layer on top, and the blocks are in the middle, and they're little sarcomeres. Those are what sarcomeres are, and that's where they came from. Now, what are sarcomeres? Well, here's sarcomeres in a heart of a human. Right there is where that membrane is, right between. There's the membrane, and these are the blocks. Now, this is a heart attack, and it's ripped. They're not supposed to be ripped, and it's supposed to be nice and stacked together, but that guy's heart failed. But it is the same blocks as here, and the same phosphate layers. Now, you say, well, Roger, that's impossible. No, it's not. This here, right here, this is from Tyson Carlson, Tyson's Mudfossil Adventures. He's out on the West Coast. This is a membrane. That is the thickness of a membrane on the coast of Oregon. That is the lower layer of the membrane. That's the upper layer. You see these little tabby looking things around the edges? They're not there for nothing. They're there because there was glue covering this whole thing, and the only entrances were through these little ion channels. And it has every other signature. This little thing here, this little thing here. I understand all of this because I've studied this very, very carefully. And so has Tyson. Tyson's doing a good job out there. Now, this is all, at one time, was just a mat. And its top was just a mat. And in between was this fluidy stuff. And this is what a membrane looks like. If you look at a regular membrane, it's the same damn thing. And this was all glued in. And now it has those little ridges on it. And that's the separation. That one is 6 feet. This here, you could hold it up in front of you and look right through it, like a window pane. So we're talking about some huge creatures. Now, as I showed you these sarcomeres, you see this? Well, this is when sarcomeres rip and they break. Now, if this was part of our Earth and one of these sarcomeres broke, it would collapse. And why would it collapse? Because there's big layers of blood. See these layers of blood? And when those layers of blood eroded out from our Earth, they created cavities and the blocks just fell down in. And where did that happen? It happened in Turkey. Here it is right here. Those are the sarcomeres. This is the olive grove. This whole area just collapsed. You see all the blood in here? You see all the sarcomeres? There's layers of, and there's thick layers of blood that service these muscles at one time. And the blood is fluidy and it runs out. It will run out in certain circumstances, and maybe even somebody tunneled into it. Who knows? But I can tell you what, these are sarcomeres. And there's some red blood over here somewhere. You see it? They need blood. And they need a lot of blood, depending upon what kind of a muscle it is. And way down deep inside, that red blood just runs out, and then the whole thing collapsed. That's in Turkey. All right, let's just talk about the universe that we're in. We know we're in something. You can look out and see this with a good telescope. You can see all of these little spots in the sky. And what are they? They are luminous bodies. They're not like the Earth or the Moon. We don't give off energy, so to speak, that's visible from a long distance as light. These have to be spitting out dipole electrons at a very high speed for them to come through all of the debris in space. And there is a ton of debris in space. They slow down. So we don't see planets because they don't give enough energy. But whenever you see these spots, they're giving off a ton of energy. Where are they? Well, somewhere out there. But they slow down as they come towards us. They're not being pulled away so that the light is stretching. That's what they're saying. Everything has to be going away. That means we're the center of the universe. Because it's going away from this side, it's going away from that side, here and there. That means we're in the middle. It's just not working. And it never did work. We are just another little speck of dust in a vast, vast, vast universe. And every one of these could be a sun. They're all stars or something. They're all spitting out something. Now, let's look deeper into this, because we now know that there's a galactic situation out there. We're in a galaxy. We are on one of these arms of a Milky Way. Let me show you approximately the way to think about how we're spinning through space. All right, it appears that all galaxies spin. There might be some debris just sort of floating around, waiting to sort of congeal, and they congeal around black holes. That's a black hole inside of a big glowing mass. The glowing mass is attracted to the darkness, and it surrounds it. So they've never seen dark matter because it's right inside of there. Now, we're on one of these arms, and we're getting pulled and dragged around here. Now, where are we? Well, nobody knows. But let's say we're right here. Let's say we're right here. There's nothing in front of us. We're in good shape. We're not banging into anything. Nobody's trying to push us out of the way. We're not going to get really buffeted by oncoming galactic material. If we're coming through here, or let's say we're coming here and we're just smashing into this sideways arm, we're in trouble. Same thing here. These things are getting smashed, cut right across them, because everybody's spinning this way and eventually getting as we spin, it's going to get more and more condensed, the atmosphere, but not in such a way as it's doing now. The reason our atmosphere is condensing now is because we're expanding it by burning, and anytime you burn something, it changes from like this size here to the size of a house. And you just get, they burn, baby, burn, baby, burn. Let's drill, pump, pump, pump. No. We need to get away from that and let our atmosphere come down. I don't know if it's possible now, but that's the problem, is our atmosphere is too pumped up. All right, I think at one point I talked to you about the Bennu being exploded. All of those little blood vessels on there are exploding out because it's being cooked from the surface. They're not impacts. This is what the aorta looks like, feeding all the red blood into the heart muscles, in addition to having just big bags of blood in there. And this is what happened. These bubble out. They blow out because they're close to the surface, and then they just pop out. You see, these are just popped out. They're not impacted in. Virtually all of these are popped out. These are no question whatsoever, these two. I mean, if you can't see that, I don't know what else to say. And then, of course, it's all the same colors of blood. The red, the black, and the yellow. Those are the states of oxygenation of iron. And these are the valve structures. I mean, there's literally no question about it. And psyche is also a heart. You see this? This one here is psyche. Now, that one's turned to metal, on the surface at least. And that indicates to me it made a very close flyby to a sun or some really, really hot, and really heated it up like smoked it up. It had to smoke up. No question whatsoever, it smoked up. Because this, if it was a heart, which it is, just exactly like this, if this went right, almost hit the sun, and it would just smoke up like a meteorite, and then take back off into space. That's what I suspect happened with Psyche. That's why it smelted. And you got to get to like close to 3,000 degrees at least to get that kind of metal. That's why this one here it's getting hit by the sun, but it's not getting to 3,000 degrees. So anyway, that's I guess I'm going to leave it at that. What I have shown you needs to be examined, with a good eye. Don't just laugh at things that you can't believe because they're just too much. I know it's too much for the average human mind. It is. If you're average or below average, well, go somewhere else. You got to be able to open your mind. You got to be able to open your mind. And if you can't open your mind, you say, "Oh, I'm open-minded, but I can't believe this." No, you're not open-minded at all then. It's like I was talking with Michael Tellinger the other day. We had a big, long conversation about all kinds of things. And he says, be open-mindedness is like being pregnant. Either you are or you're not. You can't be halfway. And that's what I get from everybody. I'm open-minded. Of course I'm open-minded. Yeah, but you can't. This is crazy. That's insane. No, it's not. You tell me what's wrong. And they can't. It's just that they cannot accept the reality of the situation we're in. Because every side has an opposition to this. The ones that hate God are against this because it shows that a lot of this stuff was true. And the ones that love God want me to stop even talking about the earth being a globe. So I'm stuck in the middle. I'm telling you, it's just I got to be honest with you. The flat Earth people, they're the ones that thumb me down. Never give me thumbs up. They want. I don't know why they want to see me fail, but I find that regularly. And the academics, I think they've just given up because I've never had a single comment from them. None, zero. They know they're in trouble, and they know if they start commenting, they're in more trouble. So here I am stuck. I hope you enjoyed listening, my good friends, and we will talk again. It's hard to give up on this, but I'm going to tell you right now, if we don't do something, this earth is in desperate, desperate, desperate trouble. And the aftermath of this current Milton hurricane is going to be the proof of the pudding, and it's not going to be good. My heart just crushes for these people. I can't imagine. I'm starting to find myself being more empathetic to think about what would it be like to be in these situations, and it's not good. It's not a good feeling, and I suppose whatever we can do to help is what we should do. And the first thing is we got to stop using this money, wasted money, to do the things that have already been done. And we got to start trying to use something like this to make free energy, or try to help somehow diminish the amount of emissions. This is killing us. It's going to burn the planet into ashes. That's my feeling. I'm sorry, but that's just a fact. All right, thank you. I love you all.